Hey everyone, so this week we're going to talk about equations of circles and parabolas. So just one quick review of the definition of circles. A circle is just all of the points that are the same distance or equidistant from a given point. One other term that you're going to hear me use throughout this unit probably is locus of points. And a locus of points is just the set of points that satisfy a given condition or multiple conditions. So let's take a look at writing the equation of a circle in standard form. So here's our circle. So we're going to pretend that this is on a coordinate grid, meaning that this point right here, the center of our circle, has coordinates. And we're going to call those HK. That's just a common convention. I'm not really even sure where it comes from. I suspect that it has something to do with variables that are available that don't typically represent something else. So that's what we're going to refer to as that's how we're going to refer to the center of our circle. And then we're going to take any point on the circle and we're just going to call that point xy. So if all of these points out here are on this circle, that means they are the same distance from HK. So what we really want to know is whatever that distance is what's going to define our circle. It's going to define all of the points on our circle. So if you remember from the distance formula, that to find the distance between these 2 points, what I need is how far apart the x's are. So I want to know how far apart this x value and this x value are. So I'm going to do x minus h to figure out how far apart those are, and then I'm going to square that. And then I'm going to add that to how far apart the y's are. And I'm going to square that, and that's going to give me the radius squared. So I'm representing this right here as the radius of my circle. And remember, this formula just comes from the Pythagorean theorem, because this distance right here, this leg of your right triangle, is how far apart the x's are. So this is just calculating how far apart the x's are. It's calculating the length of that leg. And then the same thing for the y's. So this leg of our right triangle right here is really how far apart the y's are. So y minus k is really figuring out the length of that leg right there. And then I'm just doing a squared plus b squared equals c squared, essentially. So this is it. This is your standard form for the equation of a circle. Let's take a look at some examples. So for the first one, I want to look at if you're asked to find the center and the radius of a circle. If you're given this equation, we have 3 times x plus 1 squared plus 3y squared equals 12. So if I want to know the center and the radius of this circle, if I can get this equation to look like this, then I can go ahead and just pull the coordinates of the center out of here and then take the square root of this number to get my radius. So notice I need these to be a 1, x minus h squared, and a 1, y minus k squared. So I'm going to go ahead and just divide everything on both sides by 3, and that's going to get me x plus 1 squared plus y squared equals 4. So I just went ahead and I divided every term on both sides by 3. So now for my center, my center is going to be, actually -1 is going to be my x value. So similar to when we talked about parabolas last week, because of that subtraction in the formula, this is actually going to come out as a minus instead of a plus. So my x coordinate of my center is going to be -1. And this is really the same as y minus 0 squared. So my y coordinate is going to be 0. And then for my radius, remember this 4 is equal to r squared. I know that r squared is equal to 4. So that means that r is equal to 2. So when you're solving this, obviously the radius can't be negative. So you're just taking the positive or the principal root. All right, so let's take a look at one more example. So you might have an equation given to you in this form. I know this is an equation of a circle. I can recognize it right off the bat from that x squared, y squared, at least for right now. We'll talk a little bit later about other equations that have x squareds and y squareds in them that actually aren't circles. So this is sort of an expanded form of this form of the equation right here. So we want to take this and we want to make it look like this, because once we get it here, it's pretty easy to just pick out the center and the radius. So I'm going to do this by putting my x terms together, sort of, right? I'm going to put them next to each other. And then I'm going to leave a space here, because if I want this to look like this, I'm going to have to complete the square. So I'm going to leave a blank here to complete the square for my x's, and then I'm going to do the same thing for my y's. and then I'm going to get that 6 out of the way. So I'm going to put blanks on both sides. So remember, in order to keep my equation balanced, whatever I add to the left, I have to add to the right. So over here, I already have my 1x squared, so we're good to go there. I can just take half of my middle term, which is 3, and then square that. So I'm going to add 9 to the left side, so I need to add 9 to the right side. And then here I'm going to take this. Again, I have a 1y squared, so I can go ahead and split that middle term in half, and then square that. So I'm going to get -1 is half of -2, and then square that is 1. And so over here now, this thing right here and this thing right here are both perfect squares. So I can rewrite this as x plus 3 squared, right? So I'm just taking half of positive 6. And then I can rewrite this as y minus 1 squared equals 4. So now that my equation looks like this, I can go ahead and just say, pull out the x coordinate and the y coordinate of my center. So my center is going to be the point -3, +1. So again, they're opposite of what you see there. And then my radius, just like up above, my radius squared was 4. So my radius squared is 4 here. So the radius here is going to be 2. So we're going to move on then to talk a little bit more about parabolas and equations of parabolas. So just like with a circle, there's a definition of a parabola that's similar to that of a circle. So for a parabola, though, you have a line and a point that's not on that line. And all of the points on the parabola are the same distance from both of those things. So here's what that'll look like. So my directrix is just a line. And for the purposes of this course, we're just going to talk about parabolas that open up vertically or down vertically. So we're not going to talk about parabolas that are run sideways or anything like that. So for the purposes of this course, our directrix is always going to be a horizontal line. And then we have some point here that's not on that line. And now our parabola is going to consist of all of the points that are the same distance from both this point and this line. So I think the most obvious one is the point that's halfway between here. So this distance and this distance are the same. And then, so other points that are on here are, if I go out this far from the point and then drop, remember we always measure at a right angle to the line. So when I'm measuring at the right angle to the line, here what we're saying is this distance right here and this distance right here are the same. So that point is also on my parabola. And then if I go out here, that distance and that distance are the same. So if this distance and this distance are the same, then that point is also on my parabola. So if I take a parabola and I have my focus and my directrix, then this point is the same distance from here as it is from here. This point is the same distance from here as it is from here. So these distances would be the same. Any point on this parabola will be the same distance from here as it is from here. So I know my picture's not perfect, but hopefully it's enough that you can kind of get the idea. All right, so let's take a look at an example where we're going to go ahead and write the equation of a parabola if we know the focus and the directrix. So our equation is going to be in this form. We're going back to this more standard form that we were looking at earlier in the course. You'll learn other methods for doing this when you get to pre-calc. You'll do a whole lot more with parabolas in general when you get to pre-calc. So this is just sort of a get your feet wet kind of introduction to parabolas in terms of talking about them in terms of a directrix and a focus. So the first thing we're going to do is we're going to just make a little sketch of this. So we've got a parabola. We've got our focus is the point 0, 5. And then we have our directrix down here at y equals -1. And because we're only talking about parabolas that open up or open down, that makes our directrix always horizontal, which means it's always going to be in the form y equals some number. So we're just going to sort of pick some point out we'll call xy on our parabola. So the definition of our parabola is the set of all points that are the same distance from the focus as they are from the directrix. So that means that this distance right here and this distance right here are the same. So we're going to write the formula for this distance, which is going to be x minus 0 squared. So obviously you can just write that as x squared if you want. And then plus y minus 5 squared. And then really it's the square root of that. So applying Pythagorean theorem, this is really the distance squared, so we're going to take the square root. And then the same thing for this distance right here. So if I want the distance from this point to this point, I need the coordinates of this point. So I know that because this is just a vertical line, that whatever this x-coordinate is, this is going to be the same thing. And then my y-coordinate here is given for my directrix. So this side here, the length, the distance here is going to be the square root of x minus x squared. So that's just going to be 0. Plus y, so it's going to be y minus a negative 1, it's going to be y plus 1 squared. And now we go ahead and solve this. We can go ahead and square both sides of this, and we'll get x squared plus y minus 5 squared equals, this will just be 0. So really on the right-hand side, you're just going to end up with y plus 1 squared. So as we do some more examples here, we're going to take a couple of little shortcuts. But I want to make sure that for the first one, we kind of go full on through all the steps so you understand where everything, hopefully understand where everything's coming from. So here's what I'd like for you to do right now. Go ahead and pause the video and see if you can simplify this. And if you're feeling really ambitious, you can go ahead and simplify it and then get it into y equals like this. So why don't you go ahead and pause the video, give that a shot, and then come back and see how you did. So here's where you should have ended up. So when we multiply this all out, we get y squared minus 10y plus 25. And when you multiply this out, you get y squared plus 2y plus 1. And then the y squareds conveniently cancel out. And then I'm going to combine all, it's easier to just move the y's over here and the non-y's over there. So that's what I did. I'm going to add the 10y to both sides here and subtract 1 from both sides here. So what that gets me actually is this piece right here. So that gets me to here. So I should get x squared plus 24 equals 12y. And then you can go ahead and divide everything on both sides by 12, and you end up here as your final answer. So it's not the nicest looking thing in the world, but that's what you get. All right, so let's take a look at another example. So here you're given a focus of 2, 1, and a directrix of y equals 3. If you're feeling pretty confident, you may want to go ahead and write these down, give it a go for yourself. Maybe even back the video up, and while you walk through doing this one, you look at the example we just did and see if you can see how far you can get all on your own. So if you're feeling a little ambitious right now, go ahead and pause the video, see how much of this you can do on your own, then come back and we'll go through the example with you. All right, let's see how you did. So this one's a little bit different. So you do have to be careful when you're sketching the picture. You may even want to sketch it with an x and y axis, so that you can see, because it matters whether the focus is above or below the directrix. So in this case, our y value here is 1, but the y value of our directrix is 3. So our focus is actually below our directrix. And what that's going to mean then is that our parabola opens down. So that should right there tell you something, a very key piece of information about what a is going to be in our y equals ax squared plus bx plus c. So knowing that the parabola opens down gives you a key piece of information about what type of number a is going to be. So again, I kind of went through all the steps here. So I found the distance between here and here. So it's x minus 2 squared plus y minus 1 squared, and that would equal the distance squared. So again, I would take the square root. This point is going to have the same x coordinate and then the y coordinate of 3. So if I plug it all in here, this distance, the change in x is 0 squared. So it's really going to be x minus x, which is going to become 0. And then y minus 3 squared. So it's perfectly fine with me if you want to start sort of skipping this step and just jumping right to here, because every time you're going to do the same thing. This is always going to end up being 0. So the right-hand side is always going to end up being just y minus 3 squared, or y minus whatever your directrix is. And then you're going to also square both sides. So you're going to end up here every time. So if you want to jump right to this spot, I am more than okay with you doing that. And then it's a matter of just not messing up the algebra from here, making sure that when you square these, that you're doing it as x minus 2 times x minus 2. So you end up getting 3 terms here, and so on. And then just, again, it's all combining like terms. So it's more or less arithmetic from here. because it's just being able to do things like -6 plus 2. So, and then once we get to here, go ahead and divide both sides by whatever your coefficient of y is, and you end up here. And we did get a negative value for a, which we knew or should have known we were going to get just by knowing and looking at the picture and seeing that that parabola opens down. So there's a couple of examples to hopefully get you going. And then again, if you need help, go ahead and sign up for some office hours, and hope to see some of you there.